we are a solving system of equations, and we want to graph and solve systems of linear equations in two variables. So here we have 9x minus 6y equals negative 6, and 6x minus 4y equals negative 4. So the first thing that we want to do is get these in a form that we can graph in y equals mx plus b. But right off the bat, I recognize that this linear function at the bottom is a scale factor for this one at the top. So basically what that means is if I multiply, how could I make 6 become 9? So if I divide 6 by 2, that will give me 3. So 6 divided by 2 is 3. And then 3 times 3 is 9. So if I multiply all of these by 3/2, what I get is this becomes 9x. Negative 4 divided by 2 is negative 2. Negative 2 times 3 is negative 6. And negative 4 divided by 2 is negative 2. Negative 2 times 3 is negative 6. So if we look right here, we notice that these are both the same exact equation. So if they're the same equation, you can have a scale factor, and in this case, this is a scale factor of 3/2 in order to get to this one. So if they're the same equation, then they are consistent dependent. And in this case, that is infinite solutions. We still have to be able to graph it. So in this case, when we have both variables on the left side, the way that I like to graph it is I like to just find the y and x intercept. So the y-intercept in this case we're going to have 0y. So I'm going to substitute 0 in for x. So 9 times 0 minus 6y equals negative 6. 9 times 0 is 0. Divide by negative 6. And we get y is equal to 1. So we get the ordered pair 0, 1. And I gotta make my grid or my scale. And 0, 1 is right here. So that's my y-intercept. And then I can calculate my x-intercept. And in that case, we're going to pick some x, 0. So our y value is going to be 0. So we have 9x minus 6 times 0 is equal to negative 6. Negative 6 times 0 drops out, and divide by 9. And then we get x is equal to negative 2/3. So 2/3 is right here, and then we can graph the line that goes through those. So that would be back 2/3, down 1, back 2/3, down 1, back 2/3, down 1, which would be right there. So we can graph the line that goes through there. And because we know that is consistent dependent, we know that it's the same line, so we have overlapping lines there. So I don't have to do this, but I'm just going to draw it with two colors just to show that there are two lines that overlap at the same point. And that way we have infinite solutions.